Welcome to Study Loop.
Redox is short for reduction, oxidation, reactions, which are reactions that always come in pair. In this problem, we want to balance the given redox reaction in acidic condition. So first is that we're going to separate the two into half reactions. To do that, we have to collect those species that are common. So namely, we can collect H2S with S8 because both contains S, and the other pair would be NO3 minus with NO. Next, we balance the atoms other than hydrogen and oxygen. So here we're going to, for the first equation, we're going to balance S. And to do that, we have to put 8 in front of H2S in order to form 8 sulfur on that side. Meanwhile, the other equation, nitrogen is already balanced, so we don't need to do anything on that. Next is we're going to balance the number of oxygen by adding water on the side that needs increase in the number of oxygen by adding H2O. For the first equation, we don't see any oxygen on either side, so we'll just copy it down. On the second equation, we find 3 oxygen on the left side and only 1 on the right side. So we need to increase the number of oxygen on the right side by adding 2 water. Next is we're going to balance hydrogen with H+. On the left side, we have 16 hydrogen. On the right side, we don't have any. So we're going to add 16 H+ on the right side of the first equation. On the second equation, we do have um, hydrogen on the right side that counts to 4, but none on the left side, so we need to add 4 hydrogen on the left side. So next is we're going to balance the charge by adding electrons on the side that needs decrease in the overall charge. So we count the charge on the left side of the first equation to be 0, whereas on the right side we have positive 16. So we need to bring the charge on the right side from 16 down to 0, and we do that by adding 16 electrons. On the left side of the second equation, we have a total charge of negative 4. That's positive 3. But on the right side, we have 0. So therefore, we need to bring the charge on the left side from positive 3 to down to 0. And to do that, we need to add 3 electrons. Next is we have to make sure that the two equations contain the same number of electrons. So if the first equation has 16 and the second has 3, we can make them equal by multiplying the first equation by 3 and the second equation through by 16. So doing that gives us 24 H2S forms 3 SA plus 48 H plus 48 electrons for the first equation, and the second equation becomes 16 NO3 minus plus 64 H plus 48 electrons to form 16 NO plus 32 H2. So as we now have the same number of electrons, we will then combine by eliminating the number of electrons on the two sides that are on the opposite sides of the reaction, and reducing the number of hydrogen. So all of the 48 hydrogen 48H plus in the left side, on the right side of the first equation, will reduce the 64 down to, so we just have to subtract 64 by 48, and it gives us 16H plus. And the right hand side or the left hand side of the equation then will be composed of the 24 H2S, 16 NO3 minus, and 16 H plus. On the right side, we have what was left, and that is going to be 3 S8 plus 16 NO plus 32 H2O. So this is the balanced chemical or balanced redox reaction in acidic condition. We know that this is correct because we see H plus, which indicates that it is indeed in acidic conditions. So I hope everything is clear.